In this section, we're going to discuss a case study from the book around a student class. The idea of modeling a school course in software is fairly easy to understand. We are students, we go to school, we take classes, etc. We're safely ignoring at this time the idea of time, teacher information, administrative information, etc. A course class should be able to remember and interact with its name, because that's an attribute of a course, and a list of student objects. That is, the students taking that particular course. Since there is no existing data type that models the idea of a name and a list of objects, we have to write our own. To model a course well, we need to create a new data type that aggregates the concepts of a name, a list of students, and certain operations on them. The new data type will be implemented as a Java class. We need to determine the data and the interface, the access of client code to that data. This may take a couple iterations to get right. That's normal in software design. We begin with one model and we improve upon it until we get a finished one. Determining what data is necessary is a great first step. Determining how it will be exposed to a client is a necessary second step. The set of operations on that data determines how the class will behave. That includes exposing data, modifying data, and various other types of methods. The emphasis here is on how the client will interact with this new data type. Many programmers make a mistake of thinking clients intuitively know how to do this and fail in thinking hard about how to present it in a way that's meaningful to the client. Programmers tend to think about what's cool and tend to write code that excites them but may frustrate a user. As a rule of thumb, if a class member is set one time only, we initialize it with a value and that's all. We provide that initialization function in the constructor. There's no need to have a mutator method. Another rule of thumb is that if a list of elements is manipulated, as in our case, a list of students in the course, we need to provide a way to add and remove these elements. We don't expose the container that we're storing them in, but rather our own methods to do the add and remove. For example, if we're using an array to hold the students in the class, we don't want to force the client to understand how to access and manipulate arrays. We just provide the means to add and remove students. We do the manipulation of the array. So we can come up with add student, drop student, and to get the list of all students, the get students method that provide access to modification and a listing of all students possible. Get number of students would be a possibility. It's a convenience method. If it's helpful, great. If not, don't code it. Programmers tend to think of all sorts of cool things to write, but clients don't need them. All designs have limits. In my example, if we're using an array to manage students, it's easy to use, easy to implement, but it has the downside that it's a fixed number of students maximum per class. If we try to add one more student, it'll crash our program because our array will overflow and throw an exception. No matter what number is chosen, either we won't have enough space in the classroom for all the students, or we're going to have wasted space in the array. A different container, like an array list, which will be discussed in a later section, could be used, but under the covers, it too has the exact same limitations. It's just as a dynamic structure, it works around them. No approach is perfect. We always have limits. Part of the art of software design is understanding the limits and reasonably working with them or working around them. Be sure to let your customer, your client, know of limitations that are going to affect him. Don't surprise your client. Some of our design decisions may in time prove to be poor or faulty. That's normal. Try to make designs flexible enough that in the future, class can change its design internally, still do the same thing for the client, yet fix problems or add additional function. This takes time, patience, hard thought, and experience. Learn to appreciate the process.